So we're at 12 people, and yeah, let's get started. So welcome to the Introduction to Python in 4 half-day courses. We used to do this as a one-day course, but we found people were kind of tired and burnt out at the end, so we spread it out over 2 days, and we're taking it slowly and easy, and I think some people find this course very slow, some may not. So yeah, I hope it matches a pace that's comfortable for you. So I've been programming Python for, well, it's pretty much 20 years now. I started when I was using a software package called Blender, which is for 3D graphics, and that was back in probably about 99 or 2000, and started programming in Python. And so I've gotten a lot of good use out of Python over the last 20 years, both professionally and for personal projects. We support a lot of Python programmers in our work with a research computing group and with Compute Canada. I use Python quite a lot for personal projects too. Actually, I have my latest personal project is a ukulele design. So this thing I'm holding up, every single object has been programmed in Python, and unfortunately, I didn't calculate the bridge strength well enough, so the ukulele bridge came flying off. But I guess I'll have to debug that bit of code. So yeah, you can find Python to be professionally and personally satisfying. So I hope you get a lot out of your time programming in Python. So if you look at the Etherpad, and I'll share that link one more time in the chat. There's a bunch of links to some notebooks. There's also links to the course slides. Now, I'm never going to show you the course slides during the duration of this course. You're just going to see my notebook that I'm working on. And I've provided links to each day's notebooks that I'll be using. And I'm going to start sharing my screen right now. In case you're wondering, why is he doing this? Well, this is a technique of teaching called live coding, where person at the top of the, or at the front of the class, whether it's in person or on Zoom, is basically writing code all day long during the duration of the workshop, and talking about what he's doing, and people at home are doing the same thing, and testing stuff out, trying things, and getting sort of a muscle memory and a conceptual framework for programming Python. So we'll give it a go. So so right now I have my notebook loaded. So for you guys, you either have Python installed at home, or maybe you're going through this collab like I am. So if you're running Python at home, and you have Jupyter running as sent out in our email, what I'd like you to do is start a new notebook, and make sure that you can do the following. Create a cell that says print hello world, and run it. So when I run it, boy, this takes a long time because it has to, right now it's a provisioning of virtual machine in Google's data center, and now it's running hello world. So I'd like you to give that a try. So if you're running at home, you'd start up your Jupyter Notebook server, and then type in new notebook, or sorry, select that from the menu in Jupyter. If you're doing Colab, it's pretty similar. You visit that collab.research.google.com, and then you can select new notebook, And so in the participants panel, if you can open that up, you'll notice there's, you'll see your name, and you'll see a bunch of buttons for yes, no, and go slower, go faster, more. So what I would like you to do is, once you have a notebook running and you've typed print hello world in it, can you press the green check mark for yes? And I'll try and make sure that everybody has a green check mark next to their name. If you have problems doing that, can you type a red no? And then we'll make sure that we get you up and running. And once we've done that, we'll get moving with the course content. So I'll just give you a couple of minutes to get that set up. And oh yeah, Dhruv, that's in the participants panel. So if you click the button that says participants, it'll bring up the participants panel, and you'll see the green red yes button and the red no button.
Yeah, there's also a few other options in there. You can have like a hands up, a hands down.
Yeah, I'd just like to, if you're wondering who's that guy who keeps saying stuff, that's my buddy Camille, who's my coworker. He's Camille Marcinkowski. He works for Research Computing Group, and he'll be helping me out with the workshop today. My boss Scott Dellinger is here, so if you don't like the workshop, you can send him a message. But he's here too. Good morning, Scott.
Morning. I just lurk.
Yeah. Okay, we got 5 yeses so far. Anyone who's having problems, don't be shy to click a no, and I can help you. Oh, also my coworker Erming Pei is here. He's also helping out today.
Hello, everybody.
Yeah, good morning, Erming. Oh, looks like we got 10 yeses. Okay. Well, I'm going to move on. If you are having problems, don't forget that you can message me, or you can message my my 2 co-hosts, Camille and Erming, if you have a problem. And if you don't want to, if you have an issue that you think would be interesting for the entire class, then feel free to message me, and I don't mind addressing it. If you have kind of a personal problem getting something, well, not a personal problem, but a problem getting, something working that you think just needs a little bit of help from someone, then, Camille and Erming will pull you aside and help you out. So feel free to send them a chat message.
Yeah, and the way to send the chat message is to go under chat. And at the bottom there, you have 2. You could select everyone, but you could also select an individual person.
Yeah, and don't be afraid. If you think it's something that it was useful for everyone to know, then feel free to message everyone, and we'll look at your message. But if it's I can't get my computer to work kind of problem, it's probably best to message Camille or Erming. Great. Okay. So yeah, that's great. So once you have typed in print hello world, usually you have 2 options for running that cell. So there's a control enter or shift enter. Main difference is control enter runs the cell but doesn't move on to the next cell, whereas shift enter will run the cell and it'll move on to the next cell, and it will create the new cell if there isn't a next cell. So, but So what's the output from the code? Well, it does exactly what we told it to. We told it to print a string that said hello world in it, and you'll see the output here in the notebook. If you're using Colab, you have this nice little play button that also runs your cells too. Nice. Okay, so what is a Python program? Well, it's a program that's written in Python, that's for sure. But it's usually just some text that is, that holds the Python code, and it's usually stored in a file, which is a plain text file, but it usually has an extension. So if you're writing a Python code that runs at a command line or on a server or something, usually you'll have a name like myprogram.py. So that's what your file will look like. It'll have that .py extension. Watch this when I run this cell. Python sure isn't happy with me when I do that. But if you're running a new Jupyter Notebook, so if, for example, if I go to the File menu, it'll say download IPYNB. So that stands for IPython Notebook. So your files will usually have that sort of a extension. So you might have something that looks like my notebook.ipynb, and that'll hold your Python code and all the code that's necessary to render this notebook in the Jupyter Notebook server. An interesting note is that inside these IPYNB notebooks, I think the format is actually called JSON, which is a JavaScript object notation language, but inside the JSON language formatting, there's all these little chunks of Python that are embedded in it. So yeah, so that's essentially what you're typing into a web browser right now, but behind the scenes, the notebook server is writing these IPYNB files for you. So Python notebooks, or sorry, Jupyter Notebooks have a different cell types. So right now I'm writing in a Python cell, so I can do 4 plus 6, run that, and it tells me 10, and that's valid Python code. But there's another type of cell called a text cell, which you can create at any time. So actually, let me start up a I didn't start up my own notebook server on my machine. So just out of curiosity, if you're running Python on your own computer, can you type a green yes in the participants panel? It'd be nice to know who's running in Colab and who's running in Jupyter Notebook. But I'll let me try. I want to show you both. Both experiences. So let's try. You don't have to follow along with me here. Uh-oh, that's not good. Sorry about this. This is something that I should have done before the course, but I forgot to do. Actually, you know what? I'm going to skip that for now. One of the problems is whenever I update my Mac operating system, it kills these things called virtual environments that I run Python in. So if you're in a Jupyter Notebook on your computer, you can create a new cell at any time by pressing Escape A or Escape B. And if you want to convert that to a text cell, you can press Escape T, and that will change it from Python mode to text mode. So there's these two modes, Python mode and text mode. Unfortunately, the keystrokes for both Python and for Colab and for your at-home Jupyter Notebook servers are different. If you want to know the keyboard shortcuts for Colab, there's a nice menu here that describes them. So okay. Okay, so yeah, so we can create these cells, and we can try putting some text in. So I'm going to put this hash mark here, and then I'm going to write hello world, and then I'm going to run the cell by doing Control Enter, or sorry, Shift Enter. In this case, then it types hello world. Now, if you, I'm going to clear out the check marks, and if you have a big hello world after doing a hash mark hello world, put up a green check mark. If you don't, put up a red one, and we'll sort it out. We have a report that the check marks is not working for one person. Yeah, hopefully it works for you. So to summarize, I did the hash mark hello world, and then I ran the cell by doing Shift Enter, and it prints this big heading of hello world. So I got one no. So the person who said no, so that's Dhruv. What did it do instead?
I'm trying in Jupyter Notebook.
Okay.
It's italicized in green color or turquoise color.
Okay.
And that's it. Just a hashtag hello world. And I try to run it. Does nothing, adds another cell underneath it.
Okay. Can you go back to that cell and
Yes.
press escape? Let me, maybe I will just make sure that I have my notebook working. This is me installing fresh Jupyter on my notebook. Jupyter is actually a pretty big package that has a lot of dependencies. So I don't know if you're looking at the output on my screen, but you can see all the stuff that it's downloading and setting up. So I'm going to set that up, and then I'll try and, oh, there it's done. So now I can do Jupyter Notebook. And I will do new Python 3 notebook. Okay, so here's here's the, so yeah, right here, this is a Python cell. So if I do hello world and run it, nothing shows up. So what I got to do is I have to convert it to a text cell. So there's two ways. So I have this code, this pull down that says code. I can change it to markdown, and then when I run it, it works. It's another way too. So I'll convert that back. There's a hotkey. I think maybe it's a escape M. Yeah, that converts it to markdown. So this format that it formats text in is called markdown. So that's how you would do it on the in your home version of Jupyter Notebook.
Yeah, it worked. Thank you.
Great. Okay, so yeah, right now I'm going to do a little bit of stuff that you're probably going to be thinking, hey, we came for a Python course. Why is this guy doing a bunch of text formatting? But it's one of the nice things about Jupyter Notebooks is that you can combine annotations and Python code, and this makes it a great way to do data analysis, and to share your annotations with what you're doing, and then you can distribute your notebooks to your team members or whomever it is you might think it's important, and you can let them run your code too. So it's pretty cool. So I'm going to show you some of the formatting options before we move any further. So just like there's a hash mark for a heading, you can actually do 2 hash marks for a smaller heading, or keep on going. And just remember, this has to be actually, I think this is a Python cell, so it's not going to work out for me. But let me see. Yeah. I'll be honest, I like running this stuff on my own computer more than I like running it in Colab, but Colab is so handy for so many other things, though. Oops. And I'm just clicking random buttons, it appears. Okay. So yeah, if I run this, nothing happens because I'm in a Python cell. Can I change this to a text cell? I'm going to look at the I don't see it. Okay, so I'm going to have to reproduce that in a text cell. I'll just copy and paste here. So yeah, if you do something like that, you can create these different heading levels. And you can do things like bulleted lists. So you can say first thing, second thing, third thing. You can see a nice thing on Colab is that they give you this side-by-side view between the markdown you're writing and what the rendered text will look like. That's kind of handy. So when I run that, it does the bulleted list. You can do numbered lists. So here's how you do it. So you do first thing, watch this second thing. You're probably saying, hey, Chris, you're doing it wrong. Third thing. Why is he always typing a 1? Well, if you look on the other side, Markdown knows that if you just put any number, it'll usually a 1. It'll render the actual number that you want in the order that you want. That's kind of handy because if you want to put in a middle thing, I don't know if you guys ever do this. Where you have to, you actually, when you type the 1, 2, 3, 4 yourself, when you're doing a numbered list, and then you forget something, and then you have to go back and renumber stuff. But it's kind of nice that you can just do 1 dot, 1 dot, 1 dot, 1 dot, and then it'll figure out the numbers you need. And you can do nested lists, so you can combine these. So thing, nested thing. Numbered thing. So you can create these, more complex lists where you're nesting things, and some of them are ordered, some of them are unordered. So by ordered, I mean they have the number next to the list, and yeah, some of them just have the bullets to show that they're not ordered. Okay, any questions so far? Feel free to unmute or send a message through the chat. Cool. So we've seen headings. So here's something to notice about the text that we do. So if I do Mary had a little lamb, I'm going to make 2 spaces of blank lines. So I did one line with Mary had another line with little lamb. And then I made 2 spaces and I start talking about its fleece is white as, I'll make 2 lines again. Is that how the song goes? I should probably know it at this stage in my life, but I don't. So what happened here is Markdown doesn't really care a lot about white space, individual white spaces. So it treats a line break as if it were just a space. So it writes, Mary had a little lamb as 1 line. But when I use 2 spaces, it treats that as a paragraph break and it starts a new paragraph. And then we can start again. It's white, fleece is white as, and then I do my 2 spaces and I get snow. And so this is how we can do paragraph formatting if we're writing some heavy notes in our notebook. You can create hyperlinks in your notebook if you want. So you can say, I really don't trust Google. Oh, putting on my tinfoil hat for the this course. So there we go. So when I start with square brackets, that gives the link text, and then the round brackets give me the actual link. So if I hover over the Google here, you'll see at the bottom of my browser what the link is down below. It's to https www.google.com. So you can format hyperlinks in your notebook pretty easily. I don't know if any of you guys use a service called GitHub. I use that all the time for writing for managing revisions of the code that I write, my programming code, and they use Markdown pretty heavily in their website. So if you're there's a lot of things on the internet that use Markdown. So yeah, I just mentioned that, you know, we're learning a little bit of Markdown right now to start the day, which isn't Python, but it's something that can help you, and it's goes beyond what we're doing in notebooks today. So it doesn't hurt to learn a little bit of Markdown. It's basically super easy HTML pre-processing. So what's happening is we write this Markdown code, which looks really easy. The Notebook converts that to HTML, which then gets rendered by your browser. And the good news is you didn't have to write HTML code, but you can still write web content. So it's pretty cool. So yeah, you know, some of you are probably in the sciences, and maybe you're writing stuff in LaTeX. Well, the notebook, the version of Markdown understands some LaTeX too, so that's kind of cool. So we can do something like I equals 1. So we're doing a sum from index 1 to n. And what are we summing? Well, we'll sum 2 to the power of minus I. It's approximately equal to 1. And then we close off our thing, and look at that. Look how beautiful that, actually that doesn't look that beautiful. What did I do wrong there? I'm sure there's some LaTeX guru. I probably forgot an underscore. Yeah, there we go. Some LaTeX guru might have been cringing while I was doing that. So there we go. There's a nicely formatted sum there. So you know, you can mix that with any of your other stuff. So you could make that a bullet point. Furthermore, be it known that, and then, you know, you can chuck in your little formulas wherever you want, you know, as a list or part of a paragraph, and yeah, it's pretty cool. You can make some pretty snazzy stuff with your notebook. Any questions about what we've done so far? Cool. So let's move on. So that is just a small intro to Markdown, and so we'll move on to the next section, which is about, and I'll use Markdown to indicate the next section. So we'll move on to variables and assignment, and I like to mark down the time also when I move to new sections. That'll give a good sense of our pace. So there we go. So we're ready to do some Python. So the first thing to know about Python is we have this thing called a variable. And you've seen variables in your math courses over the years. So x equals 5, y equals whatever. And we have variables in Python. So I can create a variable called age, for example, and set it equal to 42. And I can create another variable called first name. And notice I'm doing 2 lines of code in one cell. So I'll do first name equals Ahmed. And then I can run my cell, and absolutely nothing happened. So before we were getting some output, this time we're not getting output. So what we will notice though is we see the number 8 next to my cell. And that gives us an indication that the cell was run. So this is the 8th cell that was run. The notebook keeps its own internal counter sort of going as to how many cells have been run or not. And that can be handy to figure out what's going on in your notebook sometimes. So 2 variables, one is named age, the other one is named first name, and they seem to hold different things. So one looks like it holds a number, the other looks like it holds a string. So string is a collection of characters that are in order, and there's a couple of different ways to denote a string. One is with the lowercase, or sorry, the single quotes, and the other one is with double quotes. And we'll see both, and I'll probably mention this again later. But so I've given a couple of names for these variables. So variable names can have only certain things. So if I tried another variable called my age equals 50, well, that doesn't work because turns out that you can't have a negative sign, or sorry, you can't have a dash in a variable name. And can anyone guess why that is? Well, yeah. So Annika mentioned that it's the same as subtract. So yeah, so right now what Python thinks I'm doing is I'm taking a variable called my and a variable called age and subtracting from each other. And then I'm doing something really perverse by trying to assign a value to the subtraction, which doesn't make sense in any universe. So well, and it certainly doesn't make sense in Python. So don't put dashes, don't try to put dashes in your variable name. So I could have done this, my age equals 50. And Python super is, perfectly happy with that. You're wondering, well, it didn't put any output, but in a notebook, you can get it to print the value of a variable by just stating its name in a cell. So now it tells me that my age, well, that's the number 50 is stored in that variable. Jupyter Notebooks will always print the last value of a cell. So yeah, you'll see things like I could have done if I'd done the following. So I do age equals 42, first name equals Ahmed. Oops, I better put that in quotes, or the Jupyter Notebook won't like me. And then I can put age at the end, and so what it'll do is the output that I get at the end is 42 because it's printing the last value that of the value of the last line in the cell. So it's a little bit weird, but that's what it does. So no problems with underscores in variable names. Dashes, don't use them. What if I try doing h2 equals 64? Okay, that's great. Python doesn't mind if there's numbers in the variable names. What if I tried 2age equals 89? So I put the 2 at the front rather than the back. Now right now you might be getting a hint that something's not quite right because that 2 just turned green. And so there's some what's called syntax highlighting in the notebook, and sometimes it gives you a clue whether things will work or not. So I'm going to run this, and Python got mad at me. Python doesn't like having the number 2 for the beginning of a variable name. It hits that 2 and doesn't think that we're defining a variable. It thinks we're doing something with a number, and it just says, I can't handle this, and it won't run the code for us. So this this syntax where you do first name, there's actually a name for this syntax where you put a underscore between each of the words in a multi-word variable name. This is called snake case. So it's kind of like a, you know, the a little bit of a snake in between each of the letters. So that's what that underscore. That's just what programmers on the internet call this sort of convention. There's another convention called camel case, in which case I would do first name equals Bobby. So that's called camel case because what I'm doing is I have a multi-word variable name, and in this case, I'm capitalizing each new word in that variable name, so that N gets capitalized. A little bit different. So these two conventions are quite popular. You'll see them quite often in other people's code when you look at them. So snake case and camel case. Usually, if you're allowed to start with a capital letter or all capital letters. So make it a really angry looking variable name. No problem. You can do that if you like. So you can put capital letters in your variable name anywhere. I'd say don't do this for variables. Quite often, the convention, whether it's in Python language itself, which it isn't really, but in code you see on the internet, usually they reserve capital letters like all caps for constants. So you might see stuff like pi equals 3.14. Whoops, that's not pi. Well, this isn't pi either. It's just an approximation. But anyways, that's something you might see where you have a constant and you give it uppercase just to give whoever's looking at your code later a clue that you're never going to change that. Then there's the something like this where you begin with a capital and you have a capital for each in-between word. This isn't used a lot for variable names. What it is used is for something called class names. And classes are important in a type of programming called object-oriented programming. We won't have a chance really to look at that too much. We'll actually be using some objects. We just won't be creating our own ones in the duration of this, during the duration of this course. So yeah, you might see this kind of these are all called tokens. You might see this sort of token showing up from time to time, but usually it won't be a variable. It'll be something called a class. Okay, so there's lots of ways. You can actually start your variables with an underscore if you want, but I don't recommend it. Python doesn't get mad. Usually variables that begin with underscores or end with underscores, they have, again, they have a kind of an implicit meaning in Python. You can do it, but like Python won't get mad at you. But others looking at your code later, they might get mad at you. They're like, why is that person doing that? Why did they name their variable that way when they didn't need to? So I'd say avoid that. So, all right. So that's, we've created some variables and we've assigned values to them. So let's look at, we've seen the print function. So we printed hello world. Well, we can also print age, and that gets printed to the notebook output. And we can do the following. We can do first name, and I put a comma, and I'll put in a string is. I'll put another comma, and I'll put age, another comma, years old. So when I run this, it types the rather more complicated output. Ahmed is 42 years old. Now I'm putting commas between each of these between 4 different things that are getting printed. So this print thing is called a function. In fact, it's called a built-in function of Python. And we'll learn a little bit more about built-in functions and library functions a little bit later on another day. And so I'm saying print this variable called first name, and then the string is, and then the variable age, and then years old. So these 4 things are called function arguments. So first name is a function argument, the string is a function argument, age is a function argument, and years old is a function argument. And one thing you notice is I didn't put any spaces other than between the after the commas. But I could have done this. I could have said, okay, let's get rid of all these spaces here and see what happens. Well, it's still, in the output, we still get these spaces. So this print function, it puts a space between each of its arguments in its output. So be warned of that. So what if I do the following? Print last name. Well, let's see what happens. Python gets mad at me. So why did it get mad at me? It's because we didn't define the variable last name. We only defined the variable first name. So don't try and use a variable before you define it. And you define it by stuffing a value into it. So, so yeah, if we wanted to fix this, I could say last name equals Smith. And then when I do print, oops, shouldn't be in quotes here. So if I do print last name, now Python doesn't get mad at me and it prints Smith. Let me show you a very common gotcha with notebooks though. So you notice up here and so I've got cell 24 as print last name and it gave me an error. Cell 25 is last name equals Smith and that was fine. Cell number 26 says print last name and that was fine. What happens if I go back to cell 24 and try running that cell over again? Now it works and it says Smith. So this is an important thing to note is that there's a sequence and an order of these cells, but you can go back and rerun cells in any order. And what you'll see is we have 23, we have 27, 25, and 26. So cell 24 was replaced by 27. And this gives you a sense of the order of what these cells were run. Unfortunately, this little play thing is in the way of my number 25 there. So the execution order is, okay, 23 was run, then 25, then 26, then we jump up to 27. So this is a common criticism of notebooks is that they, yeah, this strange ordering thing can be misleading or confusing for people. So yeah, watch out for that if you're, I mean, I have this, my own personal habit is I'll write some code. So foo equals 5, foo plus foo, oops, foo equals foo plus 6. And I'll just write foo here. So I'll run a cell and then maybe I'll say, oh, I made a mistake. This should actually be plus 7. And I run it again. And I have this habit of I keep running cells again and over again. And that's part of my debugging strategy with my Python code. So I might run this code and then I might come back here and I'll run this code again. Oh, by the way, I accidentally pressed enter here. And guess what? Is it going to work? No, it doesn't work. Invalid syntax. So gotta watch out sometimes. Some languages that would have been perfectly fine, but with Python, it won't let you end a line with a plus without doing a line continuation, and we'll see a little bit of that in a bit. So yeah, so just keep in mind the execution order of these cells. So I see, can you print the arguments without spaces? Yeah, you can. So it doesn't matter whether I do print a, comma, u, or if I do print a, comma, space, u. And you know what? I'm gonna go crazy here. I'm gonna do the following: print a, u. I'm gonna run that. Doesn't matter. Okay, so I'm asked if I really wanted, let's say I wanted this for the output. Hey, you. How am I going to get that output? Well, there's a kind of a cheat. So print always puts spaces. You're not going to get around that, but this is something that we'll see in more detail later. But I could have done the following: print hey plus u. So I'm using what's called a string addition, also known as concatenation. So essentially this is one argument, and the string is the string hey you with no space, and I can print that. And that's one way to get hey you, but you'll never get it by putting a comma between the arguments. So if you really wanted hey you, you're probably going to want to start doing this string concatenation. Yeah, sure, if you wanted, you could do print hey you. But watch this though. Let's say we do hey equals hey and u equals u. And we got, so now they're in variables, not, they're in variables that they're mirroring their function or the value that they're holding. So if I do hey you, it's going to do with the spaces. And I can't do the following though, hey you, because it thinks that I'm trying to access a variable that's called hey you. So it's so that trick where I type print hey you up here on cell 36, that's great when you have a bit more control over what the string is. But if your string comes from the contents of variables, you have to you're going to end up having to do print hey plus u, and that will print that hey you. You notice there's no quotation marks here. I'm actually using variables called hey and u. Okay. So yeah, the thing that you've noticed is these values persist between cells. So I define hey and u in this cell, and I can still use hey and u down here in this cell, no problem. And just like when I was doing first name and last name, their values persisted between cells. They don't lose their value at the end of the cell or anything. And you've also noticed that cells can be 1 line of code, or they can be 3 lines of code, or they can be 50 lines of code, or they can be 1,000 lines of code. It all depends on what you're doing. Okay, so now we've seen some variables. We've seen how we can name them. We've seen some things we can do with them. We've seen also that we seem to have this 2 different types of variables. Ones that are strings, and So here's something that I should note is, okay, so I do hey equals hey. Oops, equals hey. And u equals u. So you see one of them single quotes, the other one's double quotes. Python doesn't care. There's absolutely no difference between defining a string with single quotes or double quotes. Kind of like the English language, where English language doesn't care either. But Python doesn't care whether you use single quotes or double quotes. There are a lot of programming languages that do care, though. So just remember that this is something specific to Python and not to programming in general. So yeah, and we can still do, watch this. I won't even do a print here. I'll just do hey plus u. And it prints out, this time we get the quotation marks, so it's returning. Instead of printing to the notebook, which print command does, this one is saying, hey, the last command was a string. So it puts in those single quotes when it prints the output here. So you see quote, quote, and up here when I did hey you, there's no quotes because I'm using the print command. Something to get used to with Jupyter Notebooks. But yeah, so there's these two types of variables. So I can create a string. Actually, there's many types of variables. We've only seen these two so far. So I can create a string called an atom name and put in a value of helium. Cool. And here's something that strings do that is kind of cool. So a string is just basically a collection of individual characters. This atom name string is a collection of 6 characters. So the first one is H, second one is an E, second one is L, second one is an I, or sorry, I keep saying second one, but you know what I mean. There's 6 characters in there. And so what if we wanted to strip off one of those characters and get its value? Well, you can do something called string indexing. And this is how you do it. You use square brackets and 0. And what will that give us? That'll give us the H. And I can do atom name index, string index of 1. That gives me the E. So now I'm plucking at those characters one at a time. Some of you might not really feel comfortable about one aspect of this is that I'm using, you might say, well, wouldn't that be great if this was 1 and this was 2? But no, in Python, we do what's called zero-based indexing. So whenever you have a string or something that kind of operates in an indexing fashion, the first index is always 0, and then 1, and then 2, and then onwards. So you don't start at 1, you start at 0. So yeah, and then we can go all the way to, in our case, atom name 5 will give us the M at the end. And what if I go over the edge? It's like, oh, what's going to happen? Okay, so there's only 6 characters in our string. The first one is index 0, the last one is index 5. If I try and grab something off the end, Python gets mad at me, and it gives an error saying string index out of range. So be careful of that. Don't go over the edge. So what if I want more than 1 characters? Well, I can do that using something called slicing. And the slice would look like this. And this will also feel weird to you. I'm actually not crazy about it either, but let's look at this. I said atom name, give me a slice from 0 as the first index, and then I put a colon, and then I put this 3. And you might say, hey, grab me 0, 1, 2, and 3 indexes. But what it really did is it grabbed 0, 1, and 2. It didn't grab that third one. So what Python does when you're slicing is it gives you everything up to, but not including that second index. So the first index is the lowest one, and the second index in the slice, or the second argument to the slice, is the thing that's just before that index in the string. So another example, Atom name. So if I do 1 and 4, any guesses to what that's gonna do before I hit run? Feel free to type it in the chat what your prediction is. Yeah. Exactly, ELI. Yeah. So if your name's Eli, well, you just got your name printed. So yeah, it does the index 1, which is the second character in the string, index 2, index 3, that's the I. So there's index 1, index 2, index 3, and then it doesn't do the 4 because it does everything up to the 4. A little bit weird. I am not crazy about the way that Python does this. It's it's surprising. And I think this sort of thing, let me see if this works. What if I go over the edge now? I'm going to say, let's go from index 3 to, let's go crazy, 1,000. What's that going to do? So that's another surprise. Python doesn't give you those outer range errors that it did when I was indexing. Because if I do atom name 1,000, Python's super angry with me. But if I slice all the way to 1,000, it says, well, I can't give you all those characters, but I'll give you what I can give you. So it gave me index 3, which is the 4th letter, index 5, which is the, index 3, which is the 4th character, index 4, which is the 5th character, index 5, which is the 6th character, index 6 doesn't exist, but it's like, meh, whatever. I'll just give you what I can. So that's something to watch out with slicing, that you're when you're slicing strings. And we'll be slicing other stuff later, not just strings. So if you're wondering, why is he spending all this time slicing strings? Well, you're basically doing some practice for some other things we're going to be slicing later as we slice and dice data. Okay. So maybe you've got a string and you want to know how many characters are in it. Well, there's another built-in function. So we've seen print. And here's another one called len. And look at that. Both of those are showing up in a little brown color there in my notebook. So that should give you a hint that they're kind of keywords. But yeah, I can do, well, let's print the length of the atom name variable. And that prints a 6. In my notebook, I could have skipped the len and just done atom name. That works too. In Python code, you have to put print statements everywhere whenever you want output. In Notebook, it always prints the last value of the cell as output. So yeah, if you want to know the length of something, you use the len function. Let me show you a common gotcha. And this is one that I get hit with all the time, because I'll be saying, okay, well, I want to create a width variable, and I want that width to be 67. And I want to create a variable for length, and I'll call it len. And I'm going to put that to 78. And then I'll do width times len to get the area. Cool, it worked. Look what I named my variable here. I named it len. And look what this thing's called. It's called len. So what's going to happen if I now try and compute the length of, let's try first name this time. Python's super angry. It says, hey, an int meaning an integer object is not callable. What happened to my len function? Well, I completely toasted it. It's destroyed. I overwrote its definition by stuffing a number into it. And that's super bad because later when I try and use len for what it was designed for, it breaks. And that's another thing about Python that I think is, well, I think other languages do it too, so I can't get angry at Python itself, but you can, it's kind of like, yeah, having a buzzsaw with the safety off. You can cut things off that you don't want to by accident. So now you're probably thinking, well, we probably have to restart everything because we've destroyed our len function. Well, there's another built-in function that can help us, and it deletes the definition of anything, really, and it's called del. So see how that's showing up as a red thing? And if I say del len, I don't get any output. But what if I do len first name now? It tells me that that first name variable held the name Ahmed, and you'll see the length is 5, and my length function has been restored. Of course, now I can't do len times width to get an area. That's a new error. But anyways, that's a common gotcha where new programmers to Python will say, yeah, I really want to name my variable len because it's going to be a length. And so what you should do is just call it length. It's more, your code is more readable when you do that anyway. So watch out for that. Okay. So yeah, and just remember meaningful, just like, I mean, len's okay and wid is okay for variable names. They're not super great. Well, actually, len's a horrible one because we just destroyed a length function. But you know, you might be tempted to do L equals 78, W equals 89, and then do L times W. And sure, Python's happy with that. But probably yourself or someone else is reading your code down the road will, you know, really appreciate if you take the time to say what you mean in your code. So if I had a choice of what kind of code I want to read, the first one or the second one, I'd definitely pick the second one. And you write your programs once. Well, hopefully you write them once, but who knows? But you and others have to read the program later, and you know, you won't be in the same headspace as you were when you wrote the program. So it's nice to have these little things that can remind you what things mean. So yeah, yeah, well, watch out for that sort of thing. So yeah, so here, when I was learning programming many years ago, one of the early exercises was to swap variables. So let's say x equals 1.0, y equals 3.0. And what if you changed your mind and you really wanted x to be 3.0 and y equals to 1.0? Well, you have to do something called a swap, because you can't just do x equals y, y equals x. Because what are you going to get? Well, let's find out. Print x and y. So right now they're both equal to the same thing, which is 3.0. So what happened here is this first line, when I did x equals y, that set x equals to 3.0, and y is still equal to 3.0. And then I set y back to it, you know, the x was 3.0, so that second line, I just shuffling these 3.0s around. So at the end, I wind up with x equals 3.0 and y equals 3.0. And so what you typically have to do is you have to create what's called a swap variable. I'm not going to put a space here because I don't need to. So just so you know, I like to format my code in a specific way. You don't have to use all these spaces that I'm putting in if you don't want to. Python's pretty forgiving with white space, so do what feels comfortable. So if I do want to swap these values, I'm going to have to create a swap variable. So swap equals x. Then I can say, so I shoved that 1.0 into swap. And now I'm going to shove that 3.0 into y, or sorry, into x. And then I can say y equals swap. So I need that third variable to hold. Why don't I edit cell number 64? Oh, I can if I want. Well, sure, I could. So I just, I'm getting a question is, why don't I just redefine the x and y's in the cell? You can do that. Sometimes you really need to shuffle values around though. So yeah, the easy way would just to be write a y here, write an x here, and it's all done with. But sometimes you don't have control over what's going on, and you really need to swap values out. So that's basically why. So at the end, when I print x and y, I get 3.0 and 1.0. Yeah. So this is how you programmatically swap two variables or two values from two variables. So the values from two variables, you swap their values. I think there's another way. I think Erming pointed this out last time, is I can always do, let's see if this works. X comma y equals y comma x. So Python might have solved this problem. So let's see what happens when I do print x comma y. So yeah, they've swapped back again. So you can, so you're probably saying, why did you go to all that bother to do that? Well, Python does have this syntax too, which uses tuples, but we're not going to get to that for a while. But all programming languages, so if you do something like C, you might need to swap values around. Certain algorithms do require you to sort of swap out values from different variables, and this is how you do a general purpose swap. In Python, this is a specific way that you could also do a swap. All right, what questions do people have? Yeah, feel free to send a question to the chat anytime, or feel free to unmute at any time. I don't mind if you unmute and ask a question too. So, great. Okay. So here's something I want you to do. I want you to predict a value. So if I do initial, here's a variable called initial. Left position equals initial, and initial equals right. So now I'm going to print initial and position. What do you predict is going to be printed here? Feel free to type it into the chat. I got one guess. Yeah, I think it's going to be right left. I see a bunch of that. Okay, and sure enough, that's how it works. So initial gets shoved into left. Position gets that value of left, and then initial gets overwritten with right. And you'll notice that position didn't get overwritten too. So just that initial variable got overwritten. So when you do that assignment position equals initial, it doesn't do this sort of long-term linking of the values, but it just does that at that one time, shoves the one value into another. I do see a question, how do you convert an integer to a string? And I'm glad that you asked that because we're going to do a whole bunch of that coming up. So hang tight, we're going to see that. And yeah, there we go. That's swapping and you know, some of the variables shuffling around that you're going to be doing. Okay, so let's say I have a number 1, 2, 3. What if I wanted that second digit, that 2? We might be tempted to do this. That's not going to work. So just remember that with strings, we can do indexing, but with numbers, we don't have that indexing ability. So the error here is int object is not subscriptable. So subscriptable just means indexing, you know, you're putting a subscript or an index value. So yeah, so that's something to watch out for. Now, suppose we really did want if we really did want that value of that 2. Well, I'll show you how we'll get that a little bit later. But yeah, here's another one where I want you to guess what it's going to do. So atom name equals carbon, and then print. Oops, wow, that's the worst print I've ever done. Print atom name 1 through 3 is sort of like about notebooks is you can do a lot of experimenting because I've got a horrible memory. I can't remember what things do all the time. So nice thing about a notebook is I could just create a cell, do a little experiment to see what it'll do, and get my answer without even going to Google. Although having said that, Google is a great resource for if you run into these questions of what Python will or won't do. But yeah, sometimes experimentation is a great way too. So can anyone guess what that's going to print? Well, I got to guess. I don't think it's quite right. That's right. So it looks like we have a few pirates in the audience. So yeah, when I print that, we get atom name 1 through 3 is R. So yeah, so remember with the index, with the slicing, so that's index 0 is the C, so that's not getting included. index 1 is the A, it gets included. Index 2 is the R. So index 2 is less than 3, it gets included. And then index 3 does not get included. So that's that weird Python stuff that with slicing that you have to watch out for. Here's something that might be surprising. So we've seen, so here's atom name is carbon. What if I did this? That kind of seems like it's going off the edge of the string, right? So 0 was the first index, 5 was the last index, the sixth character is index 5. -1 seems like it's going to do something bad. What? Printed an N. That's weird. What if I do the following? Atom name -2. Can anyone see what's going on there? That's right. So someone said last character. So yeah, -1 is the last character. So now we're indexing from the back end of the string to the forward. So index -1 in carbon is well, let's see, print. So there's our carbon. So index -1 is the N, and -2 is the O, and -3 is the B, and -4 is the R. And so we can index things backwards too. I sure hope the following doesn't work, but sometimes Python surprises me. What if I do -6? Actually, that's probably going to be the C. Yep. And what if I do -7? I sure hope this doesn't work. Phew, string index out of range. So at least that's consistent with you know, the way that the positive indexing works. The negative indexing also gets angry. So we've seen the slicing. So we did the atom name 1 through 3, and we got the R. And what if we left out that 3 though? What would happen? Oops, got to use the right type of braces. So, oops, I'm going to do 1:. Is that going to work, or will it get angry? That gives Arbon. So that colon slices all the way to the, so that colon, when there's no argument, it slices all the way to the end of the string. And of course, we can do the other experiment. It's like, okay, well, I want to leave out that first argument, and I just want to go to the 3. And so when we leave out that first argument here in the square brackets, it's kind of weird. You know, the other functions like print and len used round brackets. String slicing for indexing uses square brackets. But for slicing, if we leave out that first argument, it starts from the beginning of the string and then goes so it returns index 0, index 1, and index 2. Does not return index 3, just 0, 1, and 2 gives us car. Okay, and here's something that might seem really weird. So I left out the first argument and the last argument, and it just printed the whole string. So, or it gave us return the whole string, which is carbon. And so you might say, well, why would you ever want to do that? You already have that variable atom name that had carbon in it, and then you put a colon with or a bracket, square brackets with a colon, and it gave you the same thing back. Can anyone think when that might be useful? Well, later on we'll see multi-dimensional arrays and stuff. So maybe I'm jumping ahead too much, but we might see, 3D data, which might take three indexes And if you want to take a slice of one dimension, you might say, oh, I want the value at 4 for the x value, and then the whole y slice, and then 7. You might see weird stuff like that. So, like I say, I am jumping ahead a bit with this, but I just wanted to let you know that this bracket with just a colon in it does have value in other places, just doesn't have value right now. So let's try one, just a couple of more. So Adam name, what if we did 3 colon -1? Well, let's try -2. So any predictions as to whether that will work, and if it does, what it will give us? I see a prediction of a B. I actually have no clue what it's going to do, so I'm just going to run it. Yeah, it's a B. So how did that work? So C-A-R-B, so B is index 3, and -2 is, so -1 is the N, -2 is the O, so everything up to but not including the O. Okay, kind of makes sense in the weird Python way that it would just return a B. There's actually a third argument. So let's say I did carbon, oh, sorry, atom name. I said, well, we'll do the whole string. So from 0 to 5, and I'm going to put in a -1 now. That's weird. What's going on there? What does it give us? Oh, it gave me nothing. What? That's not what I was expecting. Okay. What if I put in a 2 instead? Well, there we go. That's interesting. So it gave me crow when I put in a 2. Can anyone guess what's happening there when I put in the 2? Yeah, every second character. So I could have also done that with atom name ::2. So go from the beginning of the string, go to the end of the string, skip every second thing. And that gave me the same thing. What if I wanted the other letters? Anyone got a guess for how I would format that? So I have CRO and I want ABN. Okay, this is what I would do. So I just start on index 1, go to the end of the string, every second one. So rather than starting on index 0, I'm starting on index 1 and doing the slice, and I get my ABN. Actually, I don't know why I tried the negative number. I thought I was going to print the string backwards. What if I did from -1 to 0? Will that work? What if I do atom name ::1? Will that work? There we go. That gave me NOBRAC, which is carbon spelled backwards. And I could probably do atom name if I really wanted to, and you probably never would, but you can also backwards and skip to the NBA. Yeah, basketball players will like that one, I guess. NBA is basketball, right? That's not baseball. Oh, shows how much of a sports fan I am. Okay, so it's 10:33 right now. We've covered a bunch of stuff. I mean, it's going a little bit slow, but that's okay, because if this is your first time seeing any programming language, may take some time getting used to doing some of this stuff. So since it's just after 10:30, I think it might be a good time to take a break. So why don't we take a 12-minute break? So back at 10:46. Well, I'm getting really specific with these times, but yeah, take a little of a break. I'll be here for a couple of minutes, and I need a break myself. If you have any questions, otherwise we'll see you shortly. So yes, what questions do people have? Okay, everyone. Hope you're able to take a break. Yeah, we'll just finishing off this section now. So so the section was on variables in assignment, and we covered a number of concepts. So we saw variables that store values. We use the print built-in function to display values from in our Jupyter cells. We notice that variables persist between cells, so you can define a variable in one cell and use it in another. We notice that variables have to be created before they're used. We can use variables in calculations, and with our string variables, we could index them to get a single character out of them. We can use slicing to get a substring, and there's this len function that we noticed it gave the length of the string, and we also noticed that we could really mess up our len function if we're not careful. So that's the len built-in function, and Python is case sensitive, so the I don't know if we really looked at that, but you know, it's first name equals Ahmed, and first name equals Billy. These are not the same thing, so we can do print first name and first name. So this is called case sensitive, where unfortunately it's spelling sensitive too. But yeah, if we spell it correctly, you see that first name with the lowercase name holds Ahmed, and first name with the uppercase name holds Billy. So it's case sensitive, and yeah, it's important to use meaningful variable names. So one last comment about slicing. Create a new cell here. So I've been slicing variable names, but if we wanted, we could slice a string directly. So here I have carbon. This is called a string literal when it's not held in a variable, but I could you know, slice and index it also directly to grab the B out. I didn't have to go through atom name. Although it holds the value of carbon, I could work on a string directly rather than holding it in a variable to do the slicing. So yeah, so if that's not clear, okay, we're going to move on to data types and type conversion. So the question earlier was, how do you convert a integer to a string? We'll see that. So data types. 10, 50. Okay. Right. So every value has a type. So we've seen two types. One is called an int. So an int looks like this, or it looks like this, or it looks like this. By the way, this is valid Python code. I'm not doing anything, but I could run it and Python doesn't get mad at me. So these are all called int types. There's floats, which stands for floating point number. 3.14, 2.7 something. Yeah, these are all floating point numbers because they have the decimal. They're not integers. And then of course we've seen the string type. And sometimes in Python that's called str for string. So good example being carbon, string type. Now, if you're ever wondering, well, what type is that value? You can use a function called type. You see that's turning green now. So I can do type 3.14, and this type function tells me, well, it's float. This is this function, of course, is is susceptible to getting overwritten because you might be tempted in your code to say, oh, well, type equals animal or something, in which case you've just destroyed the type function. So don't forget that if you do that, you can always fix that with del type. I'm not going to run this cell, but just watch out for that. Okay, so this type function, if I run it on a 3, it returns an int, and if I run it on a string, carbon, it returns str. And you can run it on just about anything in Python if you ever need to figure out what type the thing you're interested in is. I could probably do it on len even, so type of len. It says a built-in function, so it's not just for variables and values. It's also for functions. It tells you it'll tell you what the thing is, the name that you're interested in the program that's being defined, what that thing is. So yeah, and so as we've seen, certain definitely if you have an integer, you'd expect things like this to work. And they just work. Of course, only the last value got printed, so that's 9. But the other one, I could have used print. So if I wrote print there, we could have had a print 5 minus 3, print 5 plus 4. So that'll give us 2 and 9. So it seems pretty normal to use a negative and positive operators for addition and subtraction of integers. Same with 3.5 plus 9.0. That works great. And we've seen, remember where I did this? I did hey plus u. That works. So I can use the plus operator on a string. No problem. And if you recall that, I called that string concatenation. So you're just adding one string to the end of the other. That's called concatenating. We might be tempted to say, hey, you know what? I don't want hey, I want a. So I might say, okay, let's subtract that h. And Python gets angry. So right now we've noticed a difference between floating point and integers and strings. The strings don't they don't allow the minus sign. So if you think about it, that's a bit ambiguous, because if I did a word like lollipop and then subtracted L, so which L should it subtract? It's kind of an ambiguous problem. Should it get rid of all the L's in there, or should it get rid of one of the L's, and which one? So yeah, so Python doesn't handle that at all. Now in school, you probably saw multiplication, 5 times 4. Now this X here is a problem in Python. It's not going to like it. So if I ran that, it's going to say, yeah, that's invalid syntax. So in Python and pretty much every other programming language, we use this asterisk character, the star, for multiplication. And that gives us 20. And again, it works on floating point, no problem. And strings, well, no dice. You may, however, be surprised to know that this works. Hello times 5. So here I am, I'm multiplying a string and an integer, and it's giving me hello, 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 hello. So a little annoying, but it works. You can also go the other way. So if I put the 5 first and type hello, gives the same thing. And you're probably wondering, well, why would you ever want to use that? Well, let's say you wanted a separator or something for some output you're printing. So you might want to do print equals, squiggles, equals. Oops, that's got to be a string. So do that times 20. And for my output, I can have this little separator. So that's kind of handy. So it printed out equals squiggle equals 20 times, or equals tilde equals. That squiggle is often called tilde. Okay. So we've seen the built-in function len, so no problem doing this. Strings don't, they like the len function. What about integers? No dice. So integers don't do length, and you can trust me on this one, neither do floating point numbers. So here's a question that I was asked in the chat earlier. What about string conversion? Well, let's look at the following. What if I tried to add 1 plus a string of 2? Okay, Python doesn't like it because I tried to add an integer and a string. So if you think about this, this is kind of again, an ambiguous question. When I add the number 1 and the number 2, am I wanting the number 3, or am I wanting the string 1, 2, which looks like a 12? So a string with a 1 and a 2. So there's no answer for that, which is why this fails, because there's no obvious answer. So, but we can get either value by doing some type conversion. So if you remember, a string was of type str. The string has type str, and that gives us a clue as to what we can use to convert a number to a string. So str, if I do str1 plus 2, so that str function converted the number 1 into the string that holds the character 1. And then I can get that string 1, 2 that I potentially wanted. Now, what if I did want the number 3? So if I start with 1 plus 2, that means that I got to convert the second argument, the string, to a number. Can anyone guess what might help me do that? Well, an integer is of type int. Strings are of type str. Integers are of type int. So I would do 1 plus, convert the string into an int, and that will give me the 3. So that's how you convert between strings and numbers. So imagine if you type int, convert the following. If I try to convert something that's clearly, it's a string, but it's clearly not an integer, Python gets angry. So you got to make sure that your string is a nicely formatted integer, or it's not going to work. Similarly, there's a float conversion function. So if I have a string and I have 5.6667, it converts it to a floating point number of that type. And again, let me see. What's the scientific notation? Does it look something like this or something? There we go. So that's 6 times 10 to the power of 7. So it understands various representations of what a floating point number might be when it converts to a floating point number. Any questions? So we've seen plus, we've seen minus, we've seen multiplication, dividing. So let's look at that. So if I do 6 divided by 2, gives me 3.0. So what's notable about this is I've given 2 integers, 6 and 2. Rather than giving me back an integer, it gave me back a floating point number, 3.0. One thing to note is we're using Python 3. Everyone should be using Python 3 until Python 4 is released. But there is also a Python version 2 that is still in common use in a lot of packages. It's actually been end of lifed. So the Python organization no longer supports it. Don't use Python 2, but sometimes you have to because the software you want to use is still using Python 2. And the point that I wanted to make is that in Python 2, if I did 6 divided by 2, it would give me 3.0. And watch this. I'm going to put a comment in Python 2. This was the integer. So in Python 2, in Python 2, this was the integer 3, not the float 3.0, as it is in Python 3. So I'll run that and it gives me that 3.0. So we know that we're running Python 3 for a notebook instead of Python 2. If you really did want an integer though, sometimes you do, you can use this double divided by. So if I do 6 double divided by 2, I get a 3. Now that's great. I'm dividing an even number by the number 2. Nice even division. Now if I do 7 divided by 2, I get 3.5. If I do 7 double divided by 2, I get the number 3. So integer division truncates to the next, or the closest number that's lower than the value. So 49 double divided by 5 gives me 9. It would typically be 9 point, 9 point, well, 9 point something. 9.4 divided, so 9.8. So that's what the floating point value is. I don't know why it's hurt my brain thinking about that when I could have just done this. So 9.8. So yeah, it truncates down. So you'll notice that if I were rounding, that would round up, that 9.8 would round up to a 10. But in this case, the value is truncated. So the 9.8 truncates to the everything except for the decimal point. So you just get a 9. So I don't know if you remember back in the old days when you used to do dividing and you had quotients and remainders. So we could write 49 equals, I'm going to put this as a comment because it would never run as valid Python. So 49 equals 5 times 9 with remainder 4. So the 4 is the remainder. 4 is the remainder. 9 is the quotient, I think. I have a master's degree in math and I always forget this stuff. And I think the 5 is called the divisor. Really, if I'm getting this wrong, you should be typing angry messages in the chat right now. So yeah, so basically when we do this integer math with the 2 slashes, we're getting the quotient. Actually, if I got this wrong, I'm sure Camille would be typing something really angry right now. So what if you wanted that remainder? You wanted that 4. How would you get that? There's another operator on integers called the modulo operator, and it's expressed by the percent sign. So if I did 49 modulo 5, that gives me that remainder of 4. And some of you are probably saying, hey, Chris, why are you doing that? Like, I thought I gave up all this stuff in elementary school when I took arithmetic. Well, this stuff does come in handy in programming. So, for example, let's say you wanted to test whether a number, so I'm going to put it into a variable. So x equals 89. And I want to test whether x is odd or even. I can do x modulo 2. And it gives me a 1. So what if I did x equals 91, also odd? Also gives me a 1. Now what if I try x equals 90, which is even? Then x modulo 2 gives me a 0. So based on whether this modulo 2 is 0 or 1, that will give you a quick test as to whether a integer is odd or even. And yeah, this happens all the time in various programs you'll look at. Yeah, it's handy to know this modulo stuff. So for any odd number, the remainder after dividing by 2 is a 1, and for any even number, the remainder after dividing by 2 is 0. And that's how you get that odd and even test. And yeah, so any questions about the modulo operator? Okay. How about exponentiation? Well, here's how you do it in Python. So 3.0 squared looks like that. 4.0 to the power of 4. What is that? It's probably 4 times 4 times 4, 64. It's probably 256. Yeah, okay. You might be tempted to do the following. Say, hey, I want to know 7 to the power of 2. And I know that LaTeX uses this caret sign, and some languages also, programming languages, use this caret sign, this little hat thing. And I get the value of 5. Well, that's really surprising. So what's actually going on there and is a bitwise multiplication. So so this is a bit of an aside, but the binary representation of a 7 looks like this. So 1 plus 2 plus 4. And the binary representation of a 2, actually it's an exclusive OR of the bits. So and the binary representation of a 5 looks like 4 plus 1. So what's going on here? So it's everywhere that there's only every place where it's a single one, not both ones and not both zeros, just a single one, that becomes a 1 over here. So in the first place here, so 0 and 1, that's one and not 2 1s, so that one becomes a 1. Anyways, it's yeah, this is called an exclusive OR of the bits. So if you're wondering, hey, why didn't I get 49? It's because you're actually doing a bitwise arithmetic, which in an intro Python course you're not going to want to do. So just remember that you use the 2 stars for exponentiation and not that character. Okay. So let's say I have the value 3.4 and I want to know what type plus 4. What if I wanted to know the type of that result? Well, we would do the following. We do put type around the whole thing. Python tells us that the result is a float. So we can see that visually 3.4 plus 4 returns 7.4, which is a float. So that matches our intuition. So here's a little bit of an exercise. So I'm going to ask you, what do you think the most appropriate type is for the following variables? So number of days since the start of the year, time elapsed from start of the year till now in days. A serial number. So I'm going to number these. Makes it easy. 2, 3. Serial number for lab equipment. Lab specimen's age. Current population of a city. average population of a city over time. Okay, so number of days since the start of the year. What do you guys think?
Let's see. October, November, December.
I'm gonna put int for this one. Yeah, integer. What about elapsed time from the start of the year until now in days? We have this measurement of time. It's not, yeah, I think float is probably a good answer for that. You can have fractional days. What about a serial number for lab equipment? Yeah, I might be tempted to do an integer, but all these serial numbers that I see usually have like an SN, blah, blah, J, K. So yeah, it's probably string is the safest one to store for that. So elapsed specimen's age. So that's in this case, we don't really have a well-formulated problem. So could be defined in days, could be defined in seconds, could be, so this one just kind of depends. Current population of a city. Yeah, you might want to do int, but it depends on what you're doing with this value. So, let's say it's a population of New York or something, which is, I have no clue how many people are in New York, but you definitely, let's say it's 10 million and something, but you definitely, if you give people that number as the population, they probably won't like it. You might want to express it in millions, so it might be 10.5 millions. So there's a case for expressing it as a float too in some circumstances. And then the average population of a city is that's obviously going to be a float because yeah, that's averages have a divisor, so it's usually going to wind up, unless you're really lucky, it's going to wind up being a floating point number. Okay, so yeah, you can by the way, if you have a floating point number and you did want it to be an integer, you can always convert it. So 3.14 as expressed as an int is just 3, so it chops off that that tail of the decimal point. Might be interesting to try this. Negative 3.14. Is that going to give me negative 3? Gave me negative 3. So that seems reasonable. Okay. So here's no. Okay, if I have the following variables, equals 1/3 equals 1.1, question is, which of the following prints 2.0? And so I'll do print first plus float second, print second, oops, plus float third, print first, print third, first, plus int. It's getting a little crazy here. Float print int. Just look what I did there. That's not going to work, is it? Int float. Oh boy, this is crazy. I'll correct my error there. Print two point zero times second. Okay, so here's a bunch of print statements. Who thinks this first one will print 2.0? I got one vote for yes. So we'll assume that 2 votes for yes. Okay, how about the second one? So we're converting the float one, the string with a 1 in it to a float. Then we're adding the string with 1.1 to a float. So what about the second one? Yeah, I'm getting a vote for no. Okay, if I take the first one, so I'm on the third line now. If I take the first variable is 1.0, and then I take the int of 1.1, will that print a 2.0? I get 2 votes for yes, 1 for no. So 1.0 is a float. The third one is 1.1, and we convert it to an int, which chops off that 0.1. So it's 1.0 plus 1, which is 2.0. So I think that yes is reasonable. Okay, fourth one. First is 1.0, and then we take the third one and we work outwards. So third is 1.01. We convert it to a float, which is the float 1.1. So we had a string 1.1, float 1.1. Then we convert it to an int, which strips off that 0.1. So we just get a 1. So yeah, I see some people saying yes. So I think it's a yes. Last one, or fifth one is int 1.0. And then we take the third one, 1.1, convert it to a float, convert it to an int. So I see a yes and I see a no. And so I'm going to put maybe. Yeah, I think Drew, sorry, I hope I'm pronouncing your name right, but it looks like you have the rationalization for why it may not work. Okay, 2.0 times the second one. Well, is that going to be, yeah, so I think I see some no's. So let's run this. Hopefully I haven't messed up with my syntax. Yeah, What did I do there? Invalid literal for int with base 10. Okay, that's interesting. So the third one, so we got printed out 2.0, which we said was yes. 2.1 was said no, and then the third one, people thought it was a yes, but it turns out that it's actually an error. So it didn't like that we tried to convert the string 1.1 to an int. So I'm going to comment out that line because that's not going to run. Let's test out the other ones. So we get a yes. We get a no. This one we're skipping, syntax error. We got a yes, which is correct. We got a maybe, but it turns out to be a no. So the int, here the string third gets converted to a float, which converts to an int, and that other one is an int. So an int plus an int returns 2, not 2.0. And last one gave us a syntax error also. Can't multiply sequence by non-int of type float. So if we done, so we got a no, which is correct, but if we done this, we wouldn't have got the syntax error. It would have printed 1, 1. Turns out 2.0, we can't multiply. So there's some examples of weird conversions. You know, if you have to convert things back and forth. I remember before I did that thing where I'm like, okay, let's do 1, 2, 3, index 0, or index 1. We want to grab that 2 out of there, and it didn't work because you can't index a number. What you could do is do string 1, 2, 3, then take index 1, and then convert the whole thing into an int. And that will give us that 2. So yeah, I have number 1, 2, 3, convert it to a string, grab the second digit, and then as a string, so we get the string with a 2 in it. So if I hadn't added that int, we'd get quotation marks around it. Then we convert it to an int. So if you want to grab that, you know, one of the digits of a number, you can do tricks where you convert it to a string first and then convert it back to an integer. So, and that's sometimes helpful. So, so I'm not just doing this because I'm not just doing stupid Python tricks. I kind of am, but there are also these little tools that you can keep at the back of your head that can help you solve problems while you're using Python. Any questions so far? Okay, I've got a question. Are any of you guys engineers? If you're an engineer, can you press the green yes in the participants panel? Well, we got one engineer. Got some no's. 2 no's and 1 yes. Okay. So I know that at least one person will be happy with what I'm going to do next, which is complex numbers. You can do complex numbers in Python. And we might be tempted to say, okay, I want to know 4 plus 6 times I. So, because we know that I is the imaginary number. That looks like a perfectly valid complex number. Python's getting mad at me because I isn't defined. So that one engineer in the class will know that in your engineering class, you would define a complex number using a J instead of an I. And what do we get here? Whoops, what did I do? Oh, sorry, that's you need to do that. 6, there's no times, it's a J. So there we go. So it tells me 4 plus 6J. And same with here, this is still an error. So it doesn't like the I, likes the J. So whoever was originally wrote Python was probably an engineer, not not a regular person or scientist or mathematician. And yeah, you can do arithmetic on complex numbers. So if I wanted to do, what's 4 plus 5j plus 3 plus, might be tempted to put a j here, but even if you have if that the imaginary component is 1, you have to put the 1 in front. And we get, okay, 7 plus 6j. So you add the real parts to get 7. You add the imaginary parts to get 6j, and that works. And so multiplication works too. So 2 plus 1j times 2 plus 1j. So I think this should be 3. Oops, gotta put a 1 there, not an I. That 3? No, it's 3 plus 4j. Okay. So you do that distributed sort of thing. So 2 times 2 is 4. J times j is -1. So 4 plus -1 is 3. And 2 times 1j is 2j. And then you have the other 2 times 1j, which gives you 4j. So 3 plus 4j. So if you're really into complex numbers, you can do some basic stuff. You might be tempted to do, hey, I want to do Euler's law and I want to put a complex number in an exponent. This might be something that you do in mathematics, but oh, that did work. Well, I'm surprised by that. Okay, so you can do exponentiation with with complex numbers too. So that's kind of cool. Great. So that's some complex numbers that you can it's also supported to a certain extent in Python. Great. Any questions? So we're done this section, and so some of the things that we looked at, well, every value has a type, and we can use the type value, or sorry, the type function to figure out what the type of the value is. So that's a built-in function called type. Yeah, and the type of the value controls what operations can be done on the value. So sometimes you can do plus on some things, but you can't do a minus on strings, for example. And there's various things that you can do on some types, but not others. But with strings, for example, which are the tricky ones, you can add and multiply a string. Well, you can add 2 strings and you can multiply a string by a number. Strings have length, but numbers don't. So you can use that len built-in function. And yeah, sometimes when you want to combine different types, you have to do explicit conversions. Definitely when we added an int and a float, it did the conversion for us. But if we do an int and a string with a float, that's when you run into trouble. Nowadays, quite often you write programs that take input from a user. It might be a web page or it might be a program on the command line, and that input, even if they're typing a number, will come in as a string, and you end up having to convert to a float first before you can do some meaningful arithmetic with the value you get from the user. So watch out for that. Yeah, so you can do all sorts of conversions. Integers and floats pretty much operate interchangeably with a lot of things, and yeah, that's pretty much all we have to say for now for these types and the data conversions. So any questions? I'm going to start with built-in types, or built-in built-in functions and help. So it's, oops, let's keep pressing code when I want text. Okay, so built in. Now 11:36. So we won't get to the end of this section. So so I've already mentioned this, and you've seen this a little bit about comments. So hash character at the beginning of a line is a comment. So when I ran that code, nothing happened. You can also add comments to the end of the line. So I could do 6 + 7 and say, this will run. So comments are little notes you give to yourself to remind you what you're doing. And they don't actually run. And so whenever you want to add a comment, you can put a little hash mark in front of the code that you, or the text that you don't want to run, and the Python will ignore it. Of course, in a Jupyter Notebook, we also have these text cells. So sometimes that's handy where you just say, create a text cell and say, the following won't run. And then you create a code cell right after it. And that's another way where you can, in a notebook, you can annotate what you're doing, whether you're communicating to other people or whether you're just trying to put a reminder for yourself. Comments are also really handy if you're debugging. You might have age equals 5, multiplier. Oh, I don't know how to spell multiplier. Equals 40. Then age equals age times multiplier, print age. So if I run this, I'm gonna get age equals 200. But I might be debugging and I'm like, geez, this calculation here isn't working. So let's comment it out. And so sometimes you'll get people's code and you'll see all these lines that have, looks like valid Python, but you'll see a hash mark in front. Well, they're probably, whoever gave you the code probably didn't quite figure out how to get their code to work. So they were trying stuff and commenting out stuff. I know I've got a lot of code that looks like that. And so, yeah, that's what you might see. And so those are comments in Python. You can use a hash mark, or in a notebook, you can create a text cell to add some annotation. And yeah, we've seen functions so far. So we've seen a couple of built-in ones, 3 that I can think of: print, len, and type. Oh, and we've also seen str, we've seen int, and we've seen float. So that's 6 built-in functions. And we've also seen that print, for example, takes an argument. What happens if you don't give it one, though? Is it going to be happy or unhappy? Let's run it and find out. It's happy, but if you notice what happened, is it added an extra line in between. So if you print without anything in the brackets, so no function arguments, it still worked, but it printed an empty line. Now I can practice my commenting out skills. I can comment out that middle line, and I see the output. There's no line between the before and after when it ignores that middle print. But when I add it, I do get a blank line. So before, blank line, after. So it turns out that the print can take one or many arguments. We've seen it with many arguments. But it also can take 0 arguments, in which case it just prints an empty line. We've also seen len function, so it takes an argument like this. What if we run it without an argument? Len gets angry, so it says it takes exactly 1 argument. So notice that word exactly. So if I said, okay, I want to know the length of 2 strings, and I'll add the second string as another argument, Python gets mad at me because it takes exactly 1 argument. It doesn't take 0, doesn't take 2, doesn't take 15, takes 1 argument. So some functions are picky that way. And we've seen type, and you can probably guess that takes exactly 1 argument. So if I run type with no argument, what? Takes 1 or 3 arguments? Wow. I'm interested to know why that is, because I don't know. We'll find out in a moment. So there's another function called min. You can imagine how that works. So if I have min, and I put in 5 and 9, that's going to give me 1, because 1 is the minimum value. So that's what min stands for. And this is another opportunity to point out one of those gotchas. So I'm going to do this, min equals 58 in my code. So I want to store the minimum value somewhere, and I run this thing, and I do, min times 45, and I get this cool value. But then later I'm like, hey, I want to calculate a minimum. And Python's mad at me again because I accidentally wrote the definition of what min was. So it used to be a function, now it's an integer, and we can confirm that. We'll run the type function on it, and it says, hey, min is an integer. And we're like, oh no, now we got to delete all our Python code and start over and reformat our laptop. No, you don't have to go that far. But if you remember from what we did with len, we can just use the del function on min, and that'll reset it back to its value. So I can do min 1, 5, 8. And that'll return that 1 again. And of course, if I run type on min, what is min now? It's not an int anymore, it's a built-in function. So, and there's a built-in function called max, which also is another opportunity for people, if they want to choose a variable name called max, they could run into trouble. So this one works as you might expect. So max of 8, 4, and 0 is 8. And again, another built-in function. This might be interesting. What if I do min of g h and capital A? What is the minimum value there? Turns out it's capital A. You guys are probably thinking, what is this witchcraft? Well, each of these characters have, we used to say they have an ASCII value, which is a code number. Nowadays we say they have a Unicode value, and those are numbers which can be ordered. So it turns out that in this ordering, A comes before the G and the H. Of course, if we did min of G and H, we're going to get G. So the way it works in this sort of chart of values, of code values, A through lowercase a through lowercase z are all consecutive values. They come after uppercase a through uppercase z, which are all consecutive. And of course, then you also have the strings that hold, for example, 0 and 9. So 0 comes before 9 in the code chart. Sometimes this comes in handy. And you can order strings too. So it does what's called lexicographical order. I think that's what it's called. It's also sometimes called phone book order. So if I do best pizza and Royal Pizza, no endorsements here. You find that triple or quintuple A best pizza comes first. I spelled pizza wrong. Oh well. And I don't know if you guys remember phone books. I do. You often had a bunch of pizza places at the beginning of the yellow pages that all began with a bunch of A's in front of them because they all wanted to be the first pizza place in the phone book. So yeah, so the kind of comparisons that are done with strings is the same as the phone book order, which is you know, compares the first character, then the second character, and then you know, the first character has more weight than the second character, and yeah, so that's how that ordering is done with strings and the min and max characters, which, you know, might be surprising that they actually work on strings and characters at all. So okay, any questions about that? Okay, now what if I did a min with a 1, the number 1, and the string 1, or I'll do the string A. It's a big surprise. Python isn't happy with me because it can't use the less than sign, so to compare numbers and letters, or so strings and integers. So it didn't like that at all. And we saw we could do the following. We could say, hey, what's int of 3.87? That gave us a 3. So Python does this truncation after the decimal point. It just returns the integer part. May not surprise you to know that there's a function called round. So when I do 3.87, it gives me a 4. So it rounds up to the closest or down to the closest integer. So round of 3.14 is 3. And you may or may not notice this, but there's no decimal point after the 4 or the 3. So it is actually converting to an integer also. But I can convert, for example, 3.14 to 1 decimal point. So I put a second argument. So I'm rounding 3.14 to 1 decimal point. And it returns a float, 3.1. So that second argument is for how many decimal points you want to round to. Now, it's kind of weird behavior. This sometimes it returns an int. So if you give no second argument, it gives you an int. If you give it a second argument, it gives you a float. The same function is giving you different values depending on what you're doing. And you might be wondering, well, is that documented somewhere? Well, let's check out a function called help. So what I want help on? I want help on round. And yeah, we get a little bit of documentation when we do that. So help on built-in function named in module built-ins. It's called round. This ... means that it takes multiple arguments, and the specifics is first argument is a number, and then the square bracket means optional. So optional is the comma, which gives you the second argument, which is the number of digits. And what does it return? That's what this little arrow symbol is. So, well, when we give it this stuff, it returns a number. And so then the supporting text says, well, it's going to round a number to a given precision in decimal digits. The default is 0 digits. This returns an int when called with one argument. So we observe that. Otherwise, the same type as the number. N digits may be negative. Actually, let's test that. So if I do round of the integer 6 to 17 decimal points, is that going to give me 6 the integer or a really long float? Gave me 6 the integer. So the behavior seems to match what the documentation says that it'll do. Okay, so here's help. It worked on round. It probably works on max too. So I can find out what max does. This one is has some pretty crazy stuff here. So it says max works on an iterable. Yeah, it has some stuff that I don't even understand without looking at more. At this point, this is when you type Python help max into Google, and then you find some guy on the internet has really explained what this thing does. But if you need a little brief explanation, then this is good enough. So this first one I don't really understand so well, except for the iterable part. So we'll talk about that later, perhaps. The second line I do understand. So it takes a bare minimum 2 arguments. So argument 1 and argument 2. So let's see what happens if I do max of 1 on its own. It got angry. It says integer object is not iterable. Okay. So we know that if we put in 2 arguments, it seems to do something. And then we have this thing called star args, which means optional additional arguments. And anyways, it the line that we're interested in is this one with 2 or more arguments, return the largest argument. That's what max does. Kind of interested. What if I do max one string hello? Now, if you remember, strings are subscriptable, which to me sounds like they should be iterable, because that's what my programmer sense tells me. Will that return something? Yeah, that returned the O. So it took this hello as a collection of characters and returned the highest character. So this is the this falls in under this first case here. So this one argument was something that is iterable. So it has multiple parts basically, or you can loop over all the parts and it grabbed the largest value, which is the character O, which is the highest value in the alphabet. So yeah, so help is really handy for figuring out what stuff does. Okay. So do we have any questions right now? Okay. What I think I'm going to do is I'm going to end today. It's we're about 6 minutes early, but the next part is on various types of errors we can get in Python, and I don't think I would finish it in the next 6 minutes. So maybe it would be best to leave the rest for tomorrow. How's the pace? Are people finding it slow or fast? Feel free to click the go slower or go faster button in the participant panel if you'd like, and I can have a little survey as to whether things are going too fast or too slow. If they're just right, don't worry about it. That's fine too. Right. So I'll add Finn at 11:55. Okay. Great. So yeah, feel free if you have some questions, stick around. Otherwise, I think our formal workshop for today we'll end it now. So yeah, thank you for coming. And so the next session is on Thursday, and it will be at 9 a.m. at the same Zoom room. We're also using the same Etherpad. So if you need, I'll put that in the chat again in case people missed it. So here's the Etherpad. Has links to all the notebooks that I'm using. So if you weren't able to keep up, or if you just want to see what I did, feel free to click on any of those links to Colab. They're the shared version of my notebook that I've been using today. And I have ones ready to go for day 2, day 3, and day 4. So they're all listed in the Etherpad. And yeah, so we'll start with the errors in Python when we come back. But feel free to stick around if you have questions. I should also mention that we have some other workshops coming up if you're not aware of them. So tomorrow or this afternoon, there's the introduction to shell programming for high performance computing. Let me just bring up the schedule. So that's this afternoon. So the shell programming is from 1 to 4, and if you've registered, you should have got an email about that. Wednesday from 10 to 12, there's a cloud hands-on session. So if you're in the cloud intro, and also I don't know if it's still possible to register for things that aren't full up, but I'll just put the link there. So yeah, the cloud hands-on is on Wednesday. The second stuff for Python is on 9 a.m. on Thursday morning. And then in the afternoon, there's something called HPC Essentials. So that'll pick up from where HPC Shell left off, and Camille will talk about basic scheduling of jobs and stuff like that. On Friday from 10 to 12, there's an advanced cloud session, and Erming will go over running some advanced stuff in the cloud. Asked what we'll cover for Tuesday. So I'm not sure exactly how far. I can tell you what we covered last time I ran this course. I actually have all the notebooks for that too, so I could just look that up real quick. So on day 2, last time we covered. We're actually faster today than before. So last time we covered built-in functions and help. We talked about lists, and I don't know if we did dictionaries or not. So we might have done dictionaries. So we did built-in functions, error messages, lists and dictionaries. Yeah, we did do dictionaries, and we did looping. So that was our day 2 last time I did the course. So if you do have to miss it, you might want to look at that at those sections in the course notes. So yeah, so feel free for any questions. I'll be here for. Oops, I actually sent a link to something, and I accidentally sent it to my coworker Camille privately. So yeah, there we go. So that's about it for today. So feel free to stick around if you have some questions. Otherwise, we'll see you on Thursday morning.